Hello, this is Matt from Heaney Apps, and this is part 4 in our 7-part full game tutorial series where I'll be teaching you how to make the full iPhone game 7 sides in Xcode using SpriteKit and Swift. So far in our game we have the colour wheel, so our 7-sided shape, and we have all of the balls. In this video we will deal with the balls being able to hit the sides of the colour wheel. And when a ball hits a side, the ball will delete, a brand new ball will spawn, and we will check in our code to see if the colour of the ball and the side match or not. So by the end of this video, your game will look like this. So let's jump straight back into Xcode. Okay, so back into Xcode. So in this video, we want to run some code when a ball hits a side. For this, we have to set up a contact between a ball and a side. Now, contact is simply when we run some code when two objects hit each other. So when two objects overlap, we can run some code. So at the moment in our game, we can spawn a ball and the ball will move to a random side. However, nothing happens when the ball hits the side. So today, what we will do is say when a ball hits a side, we want to do 3 things. We want to see if the ball and the side match, we want to delete the ball, and we want to spawn a new ball. So, for the contacts between the ball and the sides, we have to give all of the balls and all of the sides physics bodies. A physics body is almost an extra part that we can add to our objects. An object's physics body will be attached to the object, and the physics body can be affected by forces such as gravity, and it can interact with other physics bodies. In this game, we won't be using these forces such as gravity, and we are only interested in the physics bodies interacting with each other. As an object's physics body will be the same size as the object, so the physics body of a ball will be the same size as a ball, it can give the illusion that the objects are being affected by these forces and are interacting with other objects. There are a few ways that physics bodies can interact with other physics bodies, including telling us through our code when it's touched another physics body, or a physics body can simply hit and bounce off of other physics bodies. Even though it's actually the physics body of the object doing all of the work, as each physics body will be so similar in size to the object and it will be invisible, it will look like it's actually the objects that are interacting with each other, therefore letting us set up the ball being able to interact and hit a side. So we have to give all of the balls and all of the sides physics bodies. So we will begin by adding a physics body to each of our sides. So we could add a physics body to all of our sides here in the game scene when we set up our colour wheel. However, as we know every single object that is of type side will have this physics body, what we can do is we can jump into our sideObject.swift, go to our side class and go into our initializer and here set up a physics body. That means by default any object that is of type side will now have a physics body. So here, when we set up a new side, we will say self, this affects the side we are setting up, and we will add a physics body to the side that we're setting up. So self.physicsBody equals, this will be an SK physics body, and when it comes to dealing with physics bodies, normally you want to deal with simple shapes. So as our sides are pretty much rectangles, for the physics body for our sides, we will use a rectangle, which will be the size of the side that we're setting up. So this rectangle physics body, it would ignore the sloped sides on the images that I'm using and the paid images that you guys can get. They are there just for graphic effect. And that part of each side would never actually hit a ball, just the main rectangle part would do. So rectangle physics body will work fine. You can set these up to be very accurate in terms of the actual shape of an object, but that does take quite a lot of effort for your game to do, and it might affect your game in terms of performance. So normally you want your physics bodies to be simple shapes when you can, as it's a lot less effort for our game to use these simple shapes for physics bodies. So now by default, every side will have a physics body, which will be a rectangle, which will be the same size as the side we're setting up. Okay, and just with that, all of our sides will now have a physics body. However, if we was to hit run, all of our sides will fall down the screen. And that is because when we add a physics body to an object, this object starts to become affected by all different kind of forces and impulses. And one of the big ones is gravity. So simply by adding a physics body to all of our sides are affected by gravity. Now, we obviously don't want our sides to be affected by gravity, so after setting up the physics body for the side here in the sides initializer, what we'll do, we'll take the physics body of the side we're setting up, so self.physicsBody, this is an optional, and because we are certain this side will have a physics body, we can unwrap it, so exclamation mark, dot affected by gravity equals false. So now, any object that is of type side, by default will have a physics body, but we have turned off this physics body being affected by gravity. So anything that is of type side, so effectively all of our sides, now have a physics body. We also want a physics body for all of the balls, so anything that is of type ball. So same sort of thing into the ball object, and we will do this just before we make any object that is of type ball scale in. And here we will say self.physicsBody, so set the physics body of any object that is of type ball by default to be a physics body, and as the balls are round, we will use a circle with a radius size of 55. So this is just how big the circle physics body will be for the ball. And to be honest with you, I got to this number here, so this size here, by simply playing around with this number until the size was right. And once again, we do not want the ball to be affected by gravity, so we'll switch that off there. So now, any object that is of type ball, by default, will have a physics body which is not affected by gravity. Because remember, this initializer will run on any object that is of type ball whenever we spawn a ball. So now by default, any object that is of type ball, so all of the balls, will have a physics body. Same thing with the sides. Now, any object that is of type side, so all of the sides, will now have a physics body, which will be a rectangle, which will be the same size as the side. And we said, even though we have a physics body on all of our sides, do not make our sides be affected by gravity. So just with that, any object that is of type side will have a physics body, and any object that is of type ball will also have a physics body by default. So we haven't got to do anything in the game scene, and with these physics bodies, we can now set up the contacts, so we can run some code when a ball hits a side. So when two physics bodies overlap, when they make contact, we can trigger some code to run. However, there is another way that physics bodies interact with each other. So in addition to contacts, physics bodies can collide into each other. And that means physics bodies, so effectively any object with a physics body, will sort of try to knock each other out of the way if they overlap. Now by default, every physics body will collide with every other physics body. So now, if we was to hit run, basically what would happen is all of the physics bodies, so pretty much all of our objects, will now try and bump each other out of the way, like this. All of our sides, because they're so close to each other, are trying to knock each other out of the way. They are all interacting with each other. And you'll see exactly what I mean when we spawn a ball. Because now, when we spawn a ball, when the ball hits a side, it will just simply knock the side out of the way. Like so. So the physics bodies are now interacting with each other, but in the wrong way. So we're not quite done setting up the physics bodies just yet. So let's jump back into the ball object.swift. And we now have to tell our code how we want each of our physics bodies to interact with each other. So what do we want each physics body to make contact with? And what do we want each body to collide with? So when two physics bodies collide, they will just bump each other out of the way, and when they make contact, we can trigger some code to run. Now it's very important you remember that collision and contact are different things, and remember which one is which. It might be worth making a note to yourself kind of here. You know what, let's all make a note to ourselves. So collision is when two physics bodies will bump each other out of the way. So they sort of just hit each other and they will bounce off each other. They will knock each other out of the way, however you want to word it. Contact, we can run some code when two physics bodies hit. Okay, so we don't want any of our physics bodies to collide with anything. We only want to deal with contacts. We only want to run some code when two physics bodies hit each other. So when the ball hits a side, we want to run some code. So to do this, what we have to do is put each physics body into a category. This will tell our code what kind of physics body this is. We can then use this to control what each physics body will collide with, what it can make collision with, and what it can make contact with. So this category system, this way of telling our code what kind of physics body this is, it uses numbers in a kind of binary, and that can get really confusing really quick. So before we do this, what we will do, we will model all of this information so we can do this in a much easier way. So before we do this, let's jump into our models and our data. And here, what we will do, we will set up different kind of physics body categories that we will have in our game. So we need a brand new section for physics categories. And here we will set up the different physics categories, so the different kinds of physics bodies. Then we can use these to tell our code what kind of physics body each physics body is, what other kinds of physics bodies this physics body can make contact with, and what other kind of physics bodies this physics body can collide with. So we actually need 3 different categories. So 3 different kinds of physics bodies really. We need one for the ball, one for the side. That's 2 of them. The third one will be for none. We will then use this none category to tell a physics body not to collide, so don't have any collision with any other physics body. So let's set up our physics categories. So what we're going to do, we will model these in a structure. And basically all we're going to do is just declare some constants with a name and a number value, just like we would do with any other variable or constant. Then we can use the names of these constants in our code, and our code can use the numbers. So this is kind of just like declaring any other kind of variable or constant, but we will structure all of this together. So we will say struct, and we will call this physics categories. Now in here, we will declare our different kind of physics categories. So what we will do, we will set up our 3 different kinds of physics categories, and then I'll explain exactly what's happening. So what we're going to do, in here, we will say static let. I'll explain why it's static in just a moment, but we're just declaring a brand new constant, and our first category will be called none. This will be of type an unsigned integer, 32-bit, which will hold a value. Now we have to set these number values up in a form of binary. So the number we want for none is 0. And in this form of binary, that is just 0. Okay, so that one's easy. Our second category will be for the ball. This will have a number associated to it of 1. So we will say 0B1. And our third category is for the side. And this will be 2, so 0B10. So we have now set up 3 categories. And these are simply constants called none, ball, and side, and each category has a number associated, whether it's 0, 1, or 2. So don't be put off by what these are here. These can look pretty overwhelming. This is just 2 in the way we have to do it. This is just 1 in the way we have to do it. And this is just 0 in the way that we have to do it. So we have now set up our 3 categories. And these are all modeled in the structure called physics categories. So what is this static word all about? Well, when it comes to modeling data, so storing data together in a structure, static can be a pretty powerful tool. Because basically what we've done is we have made a brand new type called physics categories. And by using the word static, these constants don't belong to an instance of this type. They belong to the type. So what we can now do as an example, so you haven't got to type this out, what we can do, we can now say physics categories dot one of our categories, and this here would represent this value here. Same with the ball, we can now say go to physics categories and go get the value for the ball. If this wasn't a static, we would then have to set up an instance of physics categories and then use our instance to get these values. But now with static, we can go straight to physics categories and get the value for one of these categories. So it's a bit like what we would do with an enum, with each enum case holding a raw value. And if you're wondering, it's probably better to use an enum if we really cared about these actual options. But in this case, the focus is on the value. So this time we will model this in a structure and get the value this way. Okay, so now we have our 3 categories. So let's use them. Command B to build because we're in a different file. And let's go into our ball object. So now what we have to do when we set up a physics body, we will say take this physics body and put this into a category. So this physics body, so the physics body of any ball that we're setting up will now be in a category which is the ball. Okay, so now the code knows exactly what kind of physics body this is going to be. We'll do the same thing for the side. So into our side class, we will say self.physicsBody, and we will put this physics body, so the physics body of any side, into a category of side. So now our code knows exactly what kind of physics body is being set up. It knows what category this physics body is in. It knows any physics body of the side has a category of side, and it knows any physics body of any ball has a category of the ball. So we can now use these categories to tell our code exactly how we want our physics bodies to behave. So back into the ball class, what we will do, we will say self.physicsBody. So the physics body of any ball that we're setting up. Dot. We will then say collision bit mask. This will say what do we want this physics body to collide with? What kind of collision should this physics body do? And as we don't want any collisions, we can say physics category .none. This will tell this physics body not to collide with anything. We can then say self.physicsBody.contact test bit mask. So what should this physics body make contact with? And we want this physics body to make contact with any physics body that is in the category of side. So now, all of the balls now have a physics body. This physics body will be in the category ball. So our code knows exactly what kind of physics body this is. We said don't let this physics body collide with anything, so no collisions, because we don't want them to just bump off of each other. And we want this physics body to make contact with any physics body that is in the category side. So the ball's physics body can now make contact with any physics body which is in the side category. And our side's physics body is in that category. So now the ball knows it can make contact with the side. So into the side class, and we'll do the same sort of thing here. We will say don't let the physics body of the side collide with anything, so collision bit mask. But we want the side to make contact with anything in the category ball. So now our side's physics body is in the category side. It knows not to collide with anything, and it knows it can make contact with any physics body that is in the category ball. And as all of the balls are in the category ball, the physics bodies of the side now know they can make contact with the ball. The ball knows not to collide with anything because we're only working with contacts, and the ball now knows it can make contact with the side. We have now fully set up physics bodies, and these physics bodies know exactly how they should behave. So hit run, and let's have a look exactly what's happening in our game. So straight away, you will now see the sides are no longer colliding with each other, so there's no collision, so they're not trying to bump each other out of the way. And if we spawn a ball, the ball will now no longer push the side out of the way. So even though everything now has a physics body, nothing's trying to push each other out of the way. Now, it looks like since the start of this video that nothing has changed in our game. It looks like it's doing the exact same thing as at the end of the previous video. However, something very big is now happening. We just can't see it yet. The ball now has a physics body, and each side now has a physics body. And these are now making contact. Our code now knows when they overlap, so when they touch. All we now have to do is to tell our game what code we want to run when the ball and the side hit. So when this contact that is happening already, when that contact begins. So back into our project, and we will go into our game scene. Okay, so in our game, we now have these two objects, the ball and the sides, that can make contact. And basically that means our code is now going to be fully aware when the ball and the side hit each other, when they start to overlap. All we now have to do is to tell our code what we want to happen when a contact has begun. So when these two objects have hit each other. So when a ball has hit a side. For this, we have to use a built-in function. So a bit like the didMoveToView, which is going to run when the scene loads up, and touchesBegan, which will run when we touch the screen, there is a function that will run when a contact has begun. And as the only contact in this game is between a ball and a side, basically this function will run when a ball has hit a side. So this function is the didBeginContact function. However, we have to do a few extra bits before we can use it. So what we have to do is enable our scene to look out for these contacts and then to run the code when the contacts have begun. So when we set up our game scene, first thing we have to do, after we say it's be an SK scene, we will say, SK physics contact delegate. This here will now let our game scene use all of the code that we need to run some code when there has been a contact. With this, we can now set up our new function. So we will go right to the very bottom for this, I think, making sure we're still in the game scene. So this here is the last closing curly bracket of our game scene, and here we will set up our didBeginContact function, this one. And this function is going to run, so any code between these two curly brackets is going to run when a contact has begun. So in this game, this code will run when a ball has hit a side. Now before we can use this, there's one more thing we have to do. So let's jump into our didMoveToView, and at the very start, we have to say self.physicsworld.contactDelegate equals self. And this here will simply tell our code to run that new function when there has been a contact in this scene. Without this line here, this function will not run when a contact has begun, and therefore nothing will happen when the ball hits the side. But with that, this function will now run when there has been a contact. So now if a ball hits a side, this code here is going to run. And there's quite a lot we want to do when the ball has hit the side. And one of the things we want to do when there's been a contact is to spawn a new ball. So we can actually use this to test this all out. So in the didBeginContact, for now, let's make our game spawn a ball. This will tell our code that when a ball has hit a side, spawn a new ball. So now, just with all of that, if we hit run, now as soon as a ball hits a side, so when there's been a contact between the ball and a side, a new ball is going to spawn. It might look like the contact is slightly off sometimes, so either for me here in the video or you on your own project, it might look like the ball isn't quite touching the side when the contact is triggered and our code runs. That is simply because of lag here on the simulator, and if you was to run this on a device, it would be fine. So let's start the game. And now when the ball hits a side, brand new ball. However, that ball that has hit a side is staying there. So if we was to spin the wheel, there's been a whole bunch of new contacts, and we're going to get lots and lots of balls. So what we want to do, when a contact has begun between a ball and a side, not only spawn a ball, but delete the ball that has hit a side. So we only really have one ball on the screen at a time. So we want to take the ball that was involved in the contact and delete it. So how can we do this? Well, when there's been a contact and this function runs, we are being passed an SK physics contact, which is called contact. So this here, contact, holds all of the information about the contact, including which two physics bodies were involved in the contact. We can use this to get the objects that were involved in the contact, and we can then use this to delete the ball. And to get access to the two physics bodies that were involved in the contact, we can take contact and we can say .body A and .body B. So body A and body B of contact are the two objects that were involved in the contact. So they are effectively the ball and the side. Now the problem is, we know that the ball and the side are being passed to us as body A and body B. We don't know which one is which. We don't know if the ball is body A or body B, and we don't know if the side is body A or body B. We know one of them is the ball and one of them is the side, but we don't know which. And it's really important that we know which one is which, because we only want to affect and delete the ball. If we was to delete the side instead of the ball, that will lead to a major problem in our game. So before we can delete the ball, we have to figure out which one is which. We would then organise all of this information in such a way that it will be really easy to delete the ball. So what we will do, we will say let, and we will set up a new constant called ball of type ball in this function. Now we won't set a value here, as we will set a value in just a few moments. We will say let side of type side, and again, do not set a value. So we've now set up an empty constant called ball of type ball and side of type side. So we will use these two constants to store the ball and the side after we figure out which object in the contact is the ball and which object is the side. As we don't know what these two constants will hold just yet, we can set these up and not give them a starting value. Then, later in this function, when we know which is which, we can set the starting values. As these are constant, so declared with let, once we set these starting values in just a moment, we would never be able to change them. But we can still later on set the starting value because we haven't given them starting values, because at the moment we don't know what they're going to hold. We've just told our code that somewhere in this function, before we want to use them, the ball constant will hold an object that is of type ball, and the side constant will hold an object that is of type side. But here, they don't hold anything, and in just a moment we will give them their starting values when we know what in the contact was the ball and what was the side. So what we will now do is figure out which of the bodies in the contact is the ball and which is the side, and set the ball to ball and side to side. So what we're going to do, to figure this out, we will say if contact.body A has a category which is the ball, then we know body A is the ball. So if this is true, we know body A is the ball, because body A has a physics category of the ball, and only the ball has a physics body which has a category of the ball. So if this is true, we know body A in the contact is the ball, and therefore body B must be the side. So what we will do, we will take ball, this from here, and we will set this to the object that is body A from the contact. So the ball is going to equal contact.body A, which is the physics body, but we want the actual object. So we will say dot node. We can force unwrap this because we know it will be there. So what this will do, this will take ball and it will set ball, this from up here, to the object which was body A in the contact. Then what we have to do is tell our code to treat this object as of type ball. So this will take the ball that we declared up here and set that to the ball that was in the contact, and we're telling our code to treat it as of type ball, because by default it will just treat it as a node, which we don't want. We want to treat it as a ball, so we'll say as ball. And if contact.body A is the ball, therefore the side must be contact.body B. So we'll grab the node from there and we'll treat that as an object which is of type side. So this is one of the options, that contact.body A is the ball. And if that is the case, we will take the node associated to body A and set that to the ball, and take the node associated to body B and set that to the side in their correct types. After this, we will say else, which will mean if body A isn't the ball, therefore body A is the side. So all we have to do this time is take the ball, set that to contact.body B, the node associated to it, as the ball, and side will equal contact.body A, the node associated, as side. Okay, so what we've done, we have declared a ball and a side. We have then figured out which one in our contact is the ball and set this to ball, and we have figured out which one in our contact is the side and set this to side. So basically we've said if body A in the contact is the ball, then set the object with body A to the ball and set the object of body B to the side. But if body A is not the ball, therefore body A is the side, we've set the ball to be the object of body B and the side as the object of body A. So after all of this, in addition to being able to spawn a ball, we can now take ball and delete it. So as a quick bit of recap, we have now taken the contact between the side and the ball. We have taken the two objects in the contact. We've figured out which one is the ball, which one is the side, and we have then deleted the ball. So let's test this out. If you have a warning error for the side, saying you haven't used the side yet, not to worry, we'll get to that in just a moment. There's mine. So for now, you will have this small warning error. And if at any point in your project, over on the left, where it normally shows your files, if that changes to show this error and you want to get back to your files, all you have to do is click on the first option, so the first tab on the left, just above where the files are, just here. Let's hit run. And now if we start the game, when a ball hits a side, not only will a new ball spawn, but the ball that has hit a side will delete. As a quick reminder, if the contacts look a little bit off, so it looks like the ball is deleting just before it actually hits a side, that's just because of the lag here in the simulator. If you run this on an actual device, it should run fine. Now at the moment, these balls just delete out of nowhere, and I'm sure by now that you know that I like to really polish things off. So what I want to do, rather than these balls just deleting, when this ball was hit a side, I want it to scale down and then delete. Just like we did with our label, so we're being consistent across everything. Just so the whole ball deleting looks a lot smoother. So at the moment, the ball is just deleting because we are just removing the ball straight from the parent. Now what we want to do is something a bit like what we did to our label in the last part, where rather than just deleting the ball, we want it to scale down and then delete, just to look a bit more polished. What we could do here is take this ball and run a sequence on it, which would scale the ball and delete it. However, we actually want every ball to be deleted like this. So what we're going to do instead is set up a method for the ball, which would delete the ball. So, because the ball is of type ball, we will jump into our ball object.swift and back into our ball class. And here, what we're going to do is set up a new method. And this would be some code that we can run on any object that is of type ball. So remove from parent is just a method that will delete an object. So if in here we was to say func and almost set up a normal function, which we would call delete, what we can do, we can have all of our code to make the ball delete in the way that we want to in here. And because this method is in the ball class, if we was to build this file, we'll come back to this in just a second, what we could do now, rather than saying ball.remove from parent, is we could say ball.delete. Take the ball and run the code in the delete method on that ball. So what do we want to happen to the ball if it runs the delete method? Well, we want it to run the action to scale down and delete. So in the delete method, we will say let scale down. This will be an action to scale down to 0 over 0.2 seconds. So any object that runs this would scale down to not being there anymore across 0.2 seconds. And then another action called delete ball, which will be remove from parent. We will set up a delete sequence, which will run scale down and then delete ball in that order, one after the other. And then all we have to do, because we're in the ball class, is say self.run delete sequence. Take the ball that we're running this method on, so the ball that we're running this code on, and make that ball run delete sequence. This will take that ball, it will scale it down, and then it will delete it. So any object that is of type ball that now runs the delete method will delete, but after scaling down. So now, as a new method, command B to build, we can just say take the ball dot delete, and this will delete the ball in the way that we want to. This will take this ball and it will do all of this on that ball. So we have now set up a new method that will delete any object that is of type ball in the way that we want to. So now, just by saying ball.delete, now if we hit run, when a ball hits the side, it's going to scale down and then delete. And it just looks a lot more polished off. So that is our ball now deleting and a ball spawning properly. So our ball deleting looks a lot more polished off. There is one more thing that we could do to the balls when they are being deleted, but this is only a very small change. And in fact, this is such a small change, I can't decide if I prefer the game with this change or without it. So rather than doing this last little change now, what we will do instead, we will finish off doing everything that we have to do for the ball to work in the way that we want it to work. And then we will come back to this small change. I will show you the game with and without this last small change, and then I'll hand it over to you guys to play around with this change and see if you like it or not. So we will come back to this very quickly when we have finished everything that is essential for us to do. But for now, when the ball hits a side, the ball will scale down, so scale out, before it is deleted. However, this could lead to a bug. Because our ball, rather than deleting straight away, now takes 0.2 seconds to delete. Because the ball is going to make that contact, scale out, and then delete. And this could lead to something bad happening. So what could happen is, the ball can hit a side and scale out, and before it deletes, so whilst it's still scaling out, if we spin the colour wheel just at the right time, one ball can make contact with two sides. So I'll try and time it right, just like that. So that ball has hit a side, and after it made that contact, it was scaling out, and before it had fully scaled out, we spun the colour wheel, so the same ball hit two sides, causing two balls to be spawned. So we have to take care of fixing this potential bug. So we have to fix this bug. And to fix this bug, what we want to do is say when there's been a contact, only let us delete the ball and spawn the ball if this ball hasn't been in a contact before. So what we want to do is we want to see if this ball is active in the game or not. Basically, when the ball is spawned, by default, it will be active in the game. It will still be in play. But as soon as it makes contact for the first time, when it starts scaling down, we want to take that ball and we want to make it no longer active. Then, when there's been a contact, we'd only do the code we need to happen if that ball involved in the contact is active. So what we want to do is, we want all of the balls, so any object that is of type ball, to have another property. This would be a variable called isActive. And this will be a boolean, which by default will start at true. So every ball will have a brand new property called isActive that will start off being true. And because we've given this a value here, we haven't got to deal with it in the initializer or any of that because it has a starting value. So any object that is of type ball will have this isActive property that by default will be set to true. Command B to build that. And because all of the balls are of type ball, each ball now has a .isActive property. So what we want to do, once there has been a contact, and we figured out which one is the ball, we want to say only do this code to delete the ball and to spawn the ball if the ball isActive property is set to true. So now when there's been a contact, only delete the ball and spawn a new ball if that ball's isActive property is set to true. Then all we have to do when the ball is deleted, in addition to scaling the ball down and deleting it, take the ball that is being deleted and set isActive to false. Command B. So now this here has completely eliminated this bug, because what we've done is said when there's been a contact, figure out which one is the ball, which one is the side. We have then said when this contact has happened, if the ball is currently active, so the ball's isActive is set to true, then delete the ball and spawn a new ball. When we delete the ball, we're setting that ball's is active to false. So if this ball was to be involved in another contact whilst it's scaling out, because the ball's is active will no longer be true, because we set it to false when we deleted the ball, this if statement will not be correct. Therefore, this code will not run. Therefore, the ball will not delete again, and we would not spawn another ball. So now each ball can only be involved in one contact. Hit run, and now if we spawn a ball, this ball will have a starting is active property of true. It hits the side, we delete the ball, we change the is active property of this ball to false. So now when it's scaling out, if we was to spin the colour wheel, this bug would just be completely avoided because we're running no more code on the ball when it has been deleted. So that bug has now been avoided. So now our ball hitting a side and deleting as another ball is spawning is all set up and ready to go. So now that we have done everything essential for the ball and this is all set up, we can jump back to that extra change that I mentioned a bit earlier on. So this is only a potential very small change, but it's things like this that can make such a big difference. At the moment, when the ball hits a side, the ball keeps moving into a side as it's scaling out. This gives this sort of effect where the ball is drifting into a side as it's scaling down. So you can keep it like this, or you can change it just a little bit so that when the ball hits a side, it stops and then scales down in the same place. You'll see what I mean. I think both look pretty good, and I will show you how we can make this small change. And now that we're pretty much done with the ball deleting, I highly recommend that you play around with both options to see what you like. This would be a major part when it comes to making your own games. Just playing around with different options and seeing what feels right to you. So to make this change, all we have to do is stop the ball from moving, and all we would do is when we run the delete method before we scale the ball down is just take self to the ball and we would say remove all actions. This would stop the ball from moving when it is hit a side, so it sort of stops entirely as it scales down. So it will now look like this. It will stop entirely as it scales down, and I, for the life of me, cannot figure out which one I prefer, so I thought I'd throw this extra little bit in at the end of this section here, so it's entirely up to you. So you can either have the ball stop in place and scale down, or sort of scale down as it keeps moving and sort of drifts into the side. If you want it to stop in place, include this line, which will stop the ball from moving when it is deleted. And if you want it to drift into the side, then don't have this line. I think I will keep that in there, but it's entirely up to you. If you go for the drifting in effect, play around with your Z positions in the game scene just a little bit to make sure the ball always drifts under the side. Okay, so we have now finished off the ball deleting and a brand new ball spawning when a ball hits a side. So now that we have done that, we can move on to the final task of today's video. We will now figure out if the ball and the side that have hit each other match or not. So if the ball and the side are the same colour or not. So back into the game scene. So all we have to do now is compare the type properties of the ball and the side that were in this contact. So we could do all of this in the did begin contact, but this is quite an important task. So what we would do after the did begin contact. So after this, we will set up a brand new function called check match, and we will run this from our did begin contact. So whenever there has been a contact, and we will pass the ball and the side that were in this contact down to this function so we can check them and keep this nice and separate, because this is a really important task. So when we run this, we will pass in a ball, which we will call ball, and a side, which we will call side. So when there has been a contact, and the ball is active, just before we delete the ball and spawn a new ball, we will run our check match function, passing in the ball and the side. This will take the ball and it will take the side, pass this into check match so we can use them down here. Okay, so passing the ball and the side into this function so we can do our check down here. Now all we have to do is literally in here, take the ball and the side that were in the contact and see if their types match. So we will say if ball, the ball that we're passing in, so therefore the ball from here, therefore the ball that was in the contact. If ball.type, which remember is that property which is holding what kind of ball this is, if that's the same as side.type, then the answer was correct. And if that's not the case and the ball's type does not match the side's type, then the ball and the side do not match when they hit, so this is incorrect. And that for checking the ball and the side when they hit, to figure out if they're the same or not, is it. That's why it was so important that we set up these type properties for the ball and the side earlier on in this series, because if we hadn't have done that, and if we had just used sprite nodes, we would now be in a position where we would be very, very stuck. And there'd be no obvious or no easy way of checking to see if the ball and the side match, and we would now be botching code, which is never good. Always remember when you're coding, almost design your code, even just in your head, around how you have to use it in the future. From as far back as the start of part 2, we had to think about our code here at the end of part 4. Always think ahead with your code, then you won't get any nasty surprises. So in the next video, we will deal with our score system, and we will add some more in here. But for now, to test this, when there's been a contact, if the ball and the side match, we will simply print correct. So that will print us a message down in the log. And if the ball and the side do not match, we will simply print incorrect. And that's it. Now, when there's been a contact, we're passing in the ball and the side to our check match function, where we're saying if the ball's type and the side's type are the same, print correct, and if they aren't, print incorrect. So before we run this, down here at the bottom, make sure this section down here at the bottom is open. It should open for you when we run this and print something to the log anyway, but we will open it up now. If you haven't got this open down here, you can open it with the buttons to toggle the view on the left, the right and the bottom of Xcode in the top right hand corner of Xcode. Make sure you have this section on the right open here, because this is where it will print it to. Hit run, and let's test this out. So now we spawn a ball, the green ball will hit the pink side, and we're printing incorrect. Incorrect again, so let's get one right. Correct. So now every time the ball hits a side that isn't the same colour, it will print incorrect, and now every time the ball hits a side that is the same colour, we're going to print correct. So now we'll set the contacts up so the ball can hit a side. When the ball hits a side, it will scale down and delete. A new ball will be spawned, and our code will figure out if the ball and the side match. So our game is now very much coming together. So that wraps up this video. We have now taken care of the balls hitting the sides. In the next video, we will take care of what we want to happen when the ball hits a side and the colours match. But for today, that is all. As always, thank you very much for watching. Leave any questions or any feedback down in the comments. Hit like, hit subscribe, and I will see you next time. Goodbye.